In this video, we're going to talk about how to simplify complex numbers. It is important to remember our properties of I, that I to the first is I to the second is -1, I to the third is -I, and I to the fourth is 1. When you are adding or subtracting complex numbers, just like in this first example here, you need to first check and make sure that your order of operations have been taken care of. So in this particular case, we need to distribute this 4 in. So my first binomial stays as 2 minus 3i. I am bringing down that subtraction sign from the original problem, and my second binomial becomes -4 plus 8i. And at this point, whether your problem is addition or subtraction, you need to pay attention to your like terms. You have real parts in both of those complex binomials. We have 2. We are subtracting a -4. Because we are subtracting a negative, it turns into a positive. So when we combine that 2 minus -4, it is going to come out to be 6. I then pay attention to my real parts that I have. I have a real part here of -3i. I am still subtracting positive 8i. So I have a -3i minus an 8i, which is going to get me -11i. And this would be my simplified version for my subtraction. The same things would apply if you were working with addition. When we are trying to simplify an I to a very high power, we do again need to remember that I's just repeat in this pattern of 4. So the trick I showed you in class is take that big power, divide it by 4, and you're going to see that this comes out to be 11.5. It does not matter how many times it has completely cycled through that pattern. What you care about is you care about what is your remainder, because that tells you where it stops in that pattern. So you can see our remainder here is 0.5. We want to pay attention to the fact that we care what our remainder is in terms of fourths. So 0.5 in terms of fourths is 2/4. This remainder, we are stopping at 2 out of 4 in the cycle. This remainder, that numerator, becomes my power of I. So in simplifying, I have I squared. I squared is equivalent to -1. If when you do that division, you get a remainder of 0.25, 0.25 is the same thing as 1/4, and this would be I to the first, so it would simplify to be I. If it ends up being 0.75, this is 3/4. Again, you care about that remainder up on the top. This would be I to the third, which would simplify to be -I. And if you end up with no remainder, that's because you are at 4 out of 4. There is no remainder. So therefore, this is I to the fourth, and it would simplify to be 4. When you're multiplying, some of you have chosen to do this with a Punnett square. You have your 5 minus 2i, and you have your 3 plus 4i. Some of you have chosen to show your distribution. However you have chosen to do this problem, we'll work it together. I'm going to choose to do it with Punnett square. This would be 15. This is a -6i. This is a 20i. And this is a -8i squared. When we write that out, we right away see that we have some like terms going on right there. So we're going to simplify, combine those. I'd have a 15 plus a 14i. And I see that I have this -8, and -8 is being multiplied by I squared. So we're going to simplify, because remember, I squared is -1. That still stays a multiplication. So I have -8 times -1, which turns out to be a +8. So I have one more simplification to do, because 15 and 8 are both real terms, so they are like terms. This would become 23 plus 14i. And that would be your final answer for a multiplication. If we are choosing to do a division, you need to multiply through by that conjugate. That conjugate is your same numbers but opposite middle terms, which in this case would be 1 plus 3i. However you choose to multiply your numerators, go ahead. And however you choose to multiply your denominators, go ahead. Whether you choose to do your distribution or whether you choose to do your Punnett squares, that doesn't matter, but we do need to multiply our numerators and multiply our denominators. Our numerator is going to come out to be 5 plus 15i plus I plus 3i squared. My denominator so far would be 1 plus 3i minus 3i minus 9i squared. I'm going to do some simplification, combining of like terms right here. I have 5 plus 16i plus 3i squared. All over, I notice that this positive 3i and negative 3i, they cancel each other out, so I have a 1 minus 9i squared. I'm going to simplify that I squared. I squared is negative 1, so this becomes 3 times negative 1, which is really a negative 3. And then I have some like terms up at the top. 5 minus 3 is going to simplify to be 2. We still have that plus 16i. In my denominator, that negative 9i squared is not going to stay as a negative 9i squared. It's going to be negative 9 times negative 1, which is a plus 9. So in my denominator, that would all simplify out to be 10. Because all of these are even, we can take a 2 out of everything and get a simplified answer of 1 plus 8i all over 5.